In this video, I will talk about how to find probabilities with normal distributions. So the goal is to find probabilities for normally distributed variables using a table and using technology. So I'm just going to jump in with a problem so you can see the steps that I take to solve this problem. So a national study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. A college student with a job is selected at random. Find the probability that the student works for less than 4 hours per week. Assume that the lengths of time college students work are normally distributed and are represented by the variable x. So when you get a word problem like this, you want to look out for the keywords. The keywords here will be normally distributed. So you know that you will be using a normal distribution. You also have to look out for the mean. They told you that the mean is 22 hours per week and the standard deviation. So let's write out the information that we know. We know that I'm going to define my variable x. X is the length of time a college student works. We know that the mean is 22 and the standard deviation is 9. And I like to draw a picture so I can figure out the area that I'm interested in. So they told us they wanted us to calculate the probability that a college student works less than 4 hours a week. Okay? So when I draw this, I know that the mean is 22. Remember, the mean is always the peak. And we're looking at less than 4. So 4 is over here to the left. And I'll shade the area to the left. Well, one way you can do this is you can go use the z-table. And I talked about the z-table in my previous video when we talked about the standard normal distribution. These numbers are not z-values or z-scores. So, for example, we cannot look up 4 in the table because 4 is not in the z-table. And once again, this is an x. So what we have to do is we need to convert that 4 to a z-score in order to use the table. So the formula for z-score is your x value minus the mean divided by the standard deviation. So we'll take 4 minus 22 all over 9 and we get negative 2. So z is negative 2. So the probability that x is less than 4 will convert to the probability that z is less than negative 2. And then you can go ahead and use the standard normal table and look for the area to the left of negative 2. So I'm not going to go back and show you the table and all that because like I said, I did that in the previous video. But the answer would be 0.0228. So the probability that the student works for less than 4 hours per week is 0.228. So that's one way of doing it. You can use technology. So I'm going to show you how to use my Excel template as well as StatCrunch. When you use Excel or StatCrunch, you do not have to convert to a z-score. You can use the values as they are. Okay? So let me go ahead and go to StatCrunch. And we're going to go to Stat, Calculators, Normal. So we know the mean is 22 and we know the standard deviation is 9. We want to find the probability that x is less than 4. So once again, we don't have to worry about converting to z-scores. We're going to use the numbers that came straight from the problem. And when I hit compute, I get the answer, 0.0228. And as you can see, the picture is drawn for you as well. And that's the same area that we were looking for. We can also use my Excel template and type in our information. The mean is 22, the standard deviation is 9, and our x is going to be 4. When I hit enter, my answers populate over here to the right, and we want less than 4. So we want this first box. And as you can see, we get the answer 0.02275, which you can just round the 7 to an 8. When you click on the box, if you look above in this big box up here, you'll see the Excel command that I use to get these answers. Right. So let's go through another problem. A survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed, keywords, normally distributed, and are represented by the variable x. A shopper enters the store. We want to find the probability that the shopper will be in the store for each interval of time listed below. So I got these two problems here. These two. Okay? And we're also going to answer the question, when 200 shoppers enter the store, how many shoppers would you expect to be in the store for each interval of time listed below? So the first thing that we're going to calculate is number one. It says, find the probability that the shopper will be in the store between 22 and 52 minutes. So basically we want this probability. Oops. We want X to be between 22 and 52 minutes. Okay? So these are X values. We have to convert these to Z-scores if we wish to use the Z-table. So once again, the Z-score is X minus the mean over the standard deviation. So I'm going to convert the 22 and the 52 to Z-scores. And I get negative 1.75 and 0.75. Then you can go ahead and use your Z-table to figure out the corresponding areas and then get the answer. So we went from X being between 22 and 52. We converted those to Z-scores. The Z-score is now between negative 1.75 and 0.75. The corresponding areas will be 0.7734 minus 0.0401. We get 0.7333. So that would be the answer. All right, so let's go ahead and do this in StatCrunch. They told us the mean is 43, and they told us the standard deviation is 12. We got to do the in between. So we got to click between up here, and we want to know the probability that a shopper is in the store between 22 and 52. And when I hit compute, I get my answer, 0.733. All right, and as you can see, we got a picture. It looks just like the picture that you saw earlier. And let's go ahead and use my template. The mean is 43, standard deviation is 12. I'm not going to put an X value there. I'm going to use the lower and upper limit because this is an in-between problem. So my lower limit is 22 and my upper limit is 52. Okay, we want the in-between one, so we want this box here, and as you can see, the answer is 0.7333, just like we calculated. All right. So the next question was, if you look here, when 200 shoppers enter the store, how many shoppers would you expect to be in the store for between 22 and 52 minutes? So what you'll do is you'll take the 200 shoppers and you multiply it by 0.7333. You get 146.66, and you can round that to 147 shoppers. So out of the 200, you should expect 147 shoppers to be in the store between 22 and 52 minutes. The next problem wanted us to calculate the probability that a shopper will be in the store more than 37 minutes. So I'll draw my picture, and we want everything greater than 37. Once again, you're going to convert this to a Z-score. You're going to take this 37, convert it to a Z-score. You get negative 0.5. Then you can go ahead and use your Z-table to figure out the area to the right. So you get an answer of 0.6915. Let's go ahead and we're going to use the same values, the same mean and the same standard deviation, but this time we want greater than 37. Once again, do not convert to a z-score when you're using technology. So we want greater than, and it said 37. We hit compute, I get my answer, 0.6915. And as you can see, the picture is the same. I'll go ahead and use my Excel template. So this time I will have an X value. I'm not doing an in-between, so I don't need my lower and upper limits. I want the X to be 37. And I want the greater than, which is here. So this answer is 0.69146 or 0.6915. All right. Okay. So let's look at one more problem. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level for U.S. adults ages 20 and older is 97 milligrams per deciliter. Assume the triglyceride levels of U.S. adults who are at least 20 years old are normally distributed with a standard deviation of 25 milligrams per deciliter. You randomly select a U.S. adult who is at least 20 years old. What is the probability that the person's triglyceride level is less than 100? Okay, triglyceride levels less than 150 milligrams per deciliter are considered normal. So I'm just going to write out what we have, and you can use Excel and StatCrunch. You can, if you have a TI-84 calculator, that does normal distributions, but I don't teach that. Minitab is another program where I don't teach that either. All right, so we know the mean is 97 and the standard deviation is 25. We want the probability that X is less than 100. Okay, I always draw a picture because it gives me a visual. So this is 97 in the middle. We want the probability that X is less than 100. So we want this area here to the left of 100. Okay, so I'm not going to go back and show you how to do it in Excel and StatCrunch, but these are the screenshots. Both of them will give you the same answer, 0.5477 for both. So the probability that the person's triglyceride level is less than 100 is about 54.8%.